We are going to do two questions from the chapter circle, including one MCQ. So let's begin with the first question. Right. So in the first question, it says a chord of a circle of radius 10 centimeters subtends right angle at the center. Then what we have to find out is the length of the chord. So let's say if I draw a circle first, and I'll take a chord. The length of the chord is what we have to find out. Let's say I made a chord over here. And this chord, say AB, is subtending a right angle at the center. So this being the center, subtending is what? Joining the endpoints of the chord. So this angle is given as 90 degree. Further, we know the radius of the circle is 10. So what we can do, we can apply Pythagoras theorem here. So AB square, the square of the hypotenuse is what? Sum of the squares of the other two sides. So this results to give you AB square as how much? 100 plus 100, right? You may directly do it as 10 root 2 if you know, but if otherwise you have to find out the square root of 200. So this is what? 100 into 2, and 100 under root is what? 10. So 10 root 2 should be the answer in this case. Now this is in the next question. It says a figure is given, two tangents RQ and RP are drawn from the same external point R. So you can see that we have been given RP and RQ as two tangents drawn from an external point R. Further, as we can see that the circle is given with center O and the value of an angle that is PRQ. This angle is given as 120 degree. This angle is given as 120 degree. Further, what we have to prove here is that OR. Yeah, this OR is equal to PR plus RQ. Now we are going to apply two properties here. One is tangent from same exterior point. So what we can say from tangent from same exterior point, this length, that means PR should be equal to RQ, right? So we can begin with writing this only. That is PR is equal to RQ, and the reason is they are tangent from the same external point. Now, what you can see here in this triangle, let's say if I talk about this triangle, let me join the point of contact with the center and consider this triangle. You just need to look into this triangle. What we know that the line joining the center to the exterior point of the tangent, line joining the center to the external point of the tangent is the bisector of the angle between the tangent, right? So we can say therefore this angle, that is angle PRO, should be how much? Half of 120, right? As you know that this whole angle was given as 120 degree. And the reason you will write down, as I said here over here, I should write down the reason over here. The reason for this is the line joining the center to the exterior point of the tangents bisects the angle between the tangent. And we know that radius is perpendicular to the tangent at the point of contact. So this angle is 90. This is 60. So by applying angle sum property, we can say this angle will be 30 degree. Right. Now, once we have got this, what we know that we have to obtain the relation of PR with OR. That's what from here I guessed it. So we are going to apply the trigonometric ratio. So as we know this angle and we need relation between perpendicular and the hypotenuse, we'll be applying sine over here. So what we can say that sine 30, well, the triangle is what? Here we are talking about the triangle OPR. So sine 30 is what? Perpendicular over hypotenuse. Perpendicular is PR and hypotenuse is OR. Sine 30 is what? Half. PR is PR over OR. Now check if you do cross multiplication, what do we get? OR is equal to 2 times PR. Further, I can write 2 times PR as PR plus PR. And what we know that PR is equal to RQ. So let this is OR. let first be PR only. What I'm going to do is to replace this PR, right? From here, replace this PR with RQ as we have proved it equal in equation 1. I think this is what we need to prove in this question. Yeah, that's what the to prove.